My fellow students, welcome back to video number 17 in this SmartPLS video series. Okay, in this video, we're going to dedicate our discussion to really important subject here. It's model fit. Okay. However, yet, in variance-based software, specifically here, we're talking about SmartPLS, the analysis of model fit, maybe the results and reporting these results may not be mature yet. Okay, so there's no much support in the literature in regards to variance-based model fit analysis, okay, or variance-based software, all right? However, sometimes, whether it is our dissertation, master thesis, or publications, some examiners or reviewers may require some model fit analysis, okay, or goodness of fit. So we have to share whether our model, the constructed model, or the hypothesis of the relationships of our constructs would fit with these simple data. All right. In SmartPLS, there are some techniques, some criteria that are used. Maybe very few are supported in the literature. Much of them is not yet mature. It needs further research, further analysis. All right, so let's just jump on our presentation here and go into the discussion, okay? So, all right. Okay, then, let me just make myself a bit larger here. All right, then, okay. Model fit here, let me just move myself a bit here. All right, so model fit, as I told you, and I am here quoting some information from the SmartPLS official website, okay? Researchers should be cautious as they mention about reporting model fit, okay? Some criteria are not yet fully understood. Some need further research. Law Model, for instance, here in 1989, set some measures for model fit analysis. However, they were only for comparative measures, okay? Like comparing with literal software, all right? So, however, in SmartPLS, we have the PLS analysis and we have the consistent PLS analysis. If we consider the consistent PLS analysis for path model that has only reflectively measured construct, then we may be interested in some more meaningful model fit analysis, okay? Comparing with covariance-based SEM via the consistent PLS analysis may result in a more comprehensive results. However, the purpose of this presentation is to give you some information, some techniques, some know-how about model fit in SmartPLS and come a bit with some conclusion that is useful. All right, that is useful. Let's proceed further. So there are some measures that can be actually considered for model fit, like we have the SRMR. We'll come to each measure in specific now. Have the SRMR, we have the exact fit criteria, NFI, chi-square, and RMS theta. Okay, maybe you may find very useful, or reportable the measures in relation with SRMR, maybe RMS theta. These are the most commonly maybe reportable, maybe NFI as well. All right, let's see. And after I do the discussion here, we're gonna move into SmartPLS and our model we have been using. We'll try to find the model fit results or analysis for the model, okay? Let's proceed further. Okay, so goodness of fit, the first is the SRMR. What is it? It is actually the difference. You can hear, if you wish, pause the video, and you can find this data on SmartPLS official website. It is SRMR, it is actually the difference between the observed correlation and the model implied correlation matrix, okay? Sorry. Okay, it assesses the average magnitude of the discrepancy. So in this analysis, we find the difference, simply the difference between observed and expected correlations, okay? Here, a value that is less than 0.10, or in a more conservative analysis, 0.018, it depends on the literature. Some researchers may go more conservative and say, no, it has to be less than 0.08. But abundantly in the literature, anything that's close to 0.10 would be considered a good model fit. So simply, if you are asked to report your model fit analysis in your thesis or dissertation, you may use SRMR if you are basing your analysis on SmartPLS. Okay, SRMR is 1. Okay, if you have anything close to 0.10 and you can cite that this is acceptable, then you may claim to have a good model fit, or your model fitting sample data. Okay, proceeding further here, the exact model fit. Actually, to me, it's not yet very clear. However, as you know, when I make my videos, I try to be as comprehensive as possible. So exact model fit, it is for the exact fit criteria, you have to compare the original value against the confidence interval created from the sampling distribution, okay? The confidence interval should include the original value, and then the upper bound of the confidence of the interval, whether you have 99% or 95%, should include the original value, should be larger than the original value of the exact, okay, the squared Euclidean distance, okay, and the geodesic distance. All right, criteria to indicate that we have a good model. Did I understand this very clearly? Not very clear to me, okay? We have here to choose the confidence interval in a way that the upper bound is at 95 minimum or 99%. Okay, here in specific, so a model would fit well the sampled data or our sample data if the difference between the correlation matrix implied by your model and the empirical correlation matrix is so small. Okay, the smaller it is, then you can claim a good model fit. Okay, so the difference between the correlation matrix implied in your model and the empirical correlation matrix should not be significant. Okay, larger than 0.05. Otherwise, if the discrepancy here, all right, if the discrepancy is significant, then we would say we're not establishing a good model fit in this regard. All right. You can simply refer to the official website, SmartPLS website, for more specific data. I'm not going to be able, it's not very, very clear to me actually, and maybe I won't be able to find or apply it in my model with SmartPLS. However, I'll come to many techniques now that I can apply once we come to SmartPLS here, and I'll show you, okay? All right, then let me proceed further. Here is an important measure. It is the normed fit index, okay, NFI. What is it? It is 1 minus chi-square simple value of the proposed model divided by the chi-square values of the null model, all right? And consequently, it has to be between 0 and 1. And the closer it is the 1, the better the fit model. Okay, this is for NFI. All right. RMS theta here. What is it? It is the root mean squared residual covariance matrix of the outer model residuals. Okay. This fit measure is only useful, we have to be careful, once we have reflective models. And as you know, in SmartPLS, we can have reflective, we can have formative, and we can have mix of both, formative and reflective. Okay, you can refer back to our prior videos in this series to find out the difference between reflective and formative models, okay? So RMS theta assesses the degree to which the outer model residuals correlate. The measure should be close to 0 to indicate a good fit. So here, okay, here, If we have any result that's close to zero, that the smaller the result or the number we get, or the reporting figures we get, the more we can claim we have a good model fit. And there are some measures that are considered as well in the model fit analysis for SmartPLS. However, it's important to note that these measures are yet in their infantry stages, very early stages, but we have to have a look on them just to have an idea. All right, let me have a look on the first measure as well. It's the composite model fit measure. And this measure is, it is one possible route. In order to obtain the composite model fit measure, we have to use formatted measurement models for all constructs, okay? And after the model estimation, we usually refer to the estimated or saturated model outcome. The second model measure here is the common factor model fit measure. And to obtain it, we have to use reflective. In the other one, we had to use formative measurement model. In this one, we use reflective measurement models for all constructs, okay? And after model estimation, we refer to the estimated or saturated model SRMR outcome, okay? Furthermore, here, we got the mixed model. In this one, in the first, we used formative measurement models. In the second one, we used the reflective. In this one, we use a mix of both, okay? This still in its early stages, and literature does not provide much support in this regard, okay? Okay, so as you notice in this, let me just go back to SmartPLS a bit and just show you how we run it. And we try the consistent PLS analysis as well as the normal PLS analysis. Okay, basic. And now I'll go to SmartPLS, share SmartPLS. Let me go a bit bigger here. Okay, SmartPLS, let me just take this off and then run the PLS algorithm. Okay, if we run the PLS algorithm here, let me, all right, let me open also the final presentation. Maybe I can refer to it. Okay, and this is here the SmartPLS. Okay, I'll just run the regular PLS algorithm and go to model fit. Okay, let me use some annotation here. Okay, just distortion annotation, spotlight. Okay, I go to the model fit here. You can see SRMR 0.08, 0.102. Okay, this is very close actually to 10, to 0.10. We can here claim that we have some model fit. Okay, at least we can. If we don't have NFI, I'd say, what I advise your students here is you have to come up with something, okay, from your analysis, okay? If you don't have NFI, you don't have any other that is supporting, but SRMR, I would report SRMR and cite it properly, okay, from the literature. And there, here, you may cautiously claim that you have a good fit for the model. Okay, RMS theta is 0.13. How much did we have it here? Did we need to have it here? I'd say it has to be close to zero. It is 0.13. It may be reportable. You may not need to report it if it's not very close to zero. All right, let me, what I did here is I run the SmartPLS. Okay, let me just close this and then run the consistent SmartPLS and see what I get, okay? Calculate, and where is the PLS algorithm and the PLS, consistent PLS algorithm, okay? I'll run the calculations, go to the model fit, and see here, I get better results, okay? Maybe with consistency, I'll have more comparable results with CB or covariance-based structural model analysis software. Okay, here we have SRMR much lower, okay? And as you know, the closer for SRMR. Let me go back to the SRMR. That's the first one here. It has to be, as I mentioned, value less than 0.10 of, or more conservative one is 0.08. What did we get? Let's see. We have 0.096 for the estimated model and 0.068 for the saturated model. This is reportable actually, but with consistent PLS, we don't have RMS data to report. All right, my fellow students, let me wrap up now. Okay, so if you're using, let me just exit, stop video. All right, don't keep video, but I don't want to share anymore. Okay, stop share. All right, stop share. All right, back to it. All right, my fellow students. So in this video, we have discussed the model fit analysis for SmartPLS. We came with the conclusion that mainly maybe we can use SRMR. This is what I got, RMS data. And these results, if they go close to the acceptable and supported the threshold in the literature, then we report them and we can report our data and have a good model fit. All right, analysis. Okay, so this is actually for video number 16 or 17, focusing on a model fit for variance-based software, which is SmartPLS here. All right, stay tuned for coming videos. We're going to dive into much more details. Okay, Dr.